Next up, they want the empirical formula. So they say it's a chloride of germanium. So it's just germanium and chlorine. So a sample containing 64.5 gram. This is the whole thing. So you have 42.6 gram of chlorine. Therefore, your mass of germanium atom is going to be 64.5 minus 42.6. The most common mistake is people would think, they didn't give me the mass of this. I'll put 64.5 there. But 64.5 is chloride of germanium. It's the whole thing. Okay, you got to read the question and interpret the language, unfortunately. So it's 21.9 gram of germanium atom. So this plus this give you the chloride of germanium, that is 64.5. Okay, that's what the question really is asking. So you got to think carefully before you jump to conclusion, alright? So the mole is going to be the mass over the atomic mass. Empirical formula definition: simplest ratio of atoms. These are atoms. I use atomic mass. I don't use molecular mass. It's not CO2, it's atom. Okay? So that's actually quite common mistake amongst O-level students. In fact, a lot of O-level students actually bring it up to A-level as well. So you gotta keep an eye out for this kind of thing. So divide by the smallest number to get the simplest ratio. So it's GeCl4. As you would expect, a group 4 outer shell electrons. So they didn't ask you to draw the dot and cross, but I could easily draw the display formula. It looks like that. You can imagine the similarity to CH4 because, chlorine also likes to form one covalent bond, right? Just like hydrogen. So you can relate the two kind of structures together. So now the chloride germanium has a boiling point of that. In fact, I've given it away by showing you that it's actually existing as single discrete molecule. So that's why it's simple molecular structure. And they want the bonding of this chloride. So it has germanium chlorine covalent bond. They're not asking you why the boiling point is low, but I can also say in weak intermolecular forces. So inter refers to between. Molecular means between the molecules. Okay, so intermolecular refers to between the molecule. Between the GeCl4 molecules. And because you have two different kind of bond, two different kind of electrostatic force attraction, and the low boiling point is a result of you just breaking this and not breaking that. All right. Anyway, empirical formula, and they told you that it's a hydrocarbon. Hydrocarbon means it contains carbon and hydrogen atoms only. Alright, that's the definition of hydrocarbon. So you have 90% by mass of carbon. So percentage by mass, you can say by 100 gram mass. So if you have 90%, that is equivalent to 90 gram and 10 there, because only carbon and hydrogen atoms, right? So the mole is going to be the mass over the MR, well, the mass over the relative atomic mass. That's going to give you 90 divided by 12 is 7.5. It's going to give you 10. You don't run out when it's a nice number like this. You try to make this a whole number by dividing simplest ratio. I mean 7.5 divided 7.5 is 1. 10 divided by 7.5 is 1.33. Sorry, this is what I mean. You do not run this up into 1 because it looks so close to 1. 1.33 is also the same as 1 over 3. It's also the same as 4 over 3. When you see something 0.33 or 0.25, in fact 0.33, 0.67, 667, something like that. Okay, those are 1 over 3. This is 2 over 3. Okay, things like 0.25, there's 1 over 4. 0.75, there's 3 over 4. So you can simplify it. Okay, you can simplify it by multiplying by 3. Then 4 over 3 multiplied by 3. This one you need to multiply by 3. This one you need to multiply by 3. So actually your empirical formula is C3H4. 1.33 times 3 is going to give you 3.99, which is almost 4. That is the whole number that is closest. 1.33 is not 1, yeah, okay? That's why questions like this can be confusing if you are not capable enough in mathematics ability, yeah? So that's why you have to improve your understanding of your primary school mathematics, okay? I'm sure you do all this in your primary school and you cover this again in lower and upper secondary. If you want to work out molecular formula, you need the molecular mass, okay? The molecular mass means the total mass of the single molecule, okay? Whereas this one is just the simplest ratio of the atoms, simplest ratio of the carbon and hydrogen atoms in this hydrocarbon. All right, so you need the molecular mass. That's actually what we call the MR usually, right? Of the molecule, All right. Methyl propane is a saturated hydrocarbon. What does saturated mean? That means that all the carbon-carbon bond is single bond, yeah? Only carbon-carbon single bond. I don't think they ask you to define here, but that's all right. So they give you the molecular mass. What is the molecular formula? From methyl propane, which is this, is C4H34367110. Well, I should know CnH2n plus 2, yeah, because it's a normal alkane. Now you do this reaction called substitution. In O level, you do substitution reaction, right? Alkane reacts with UV light. That means this compound has chlorine. It's no longer hydrocarbon, it has chlorine because you have done substitution, yeah? The question is, how many chlorine? All right? This MR is going to be 12 times 4 because there are 4 carbon. And then there's 10 hydrogen, so 10 times 1, so 48, 58. All right? You need to think carefully. Replace means you take out and you substitute it. You replace it with chlorine. If you replace it with chlorine, if C4H9Cl, what is your MR? That's what I'm saying, okay? You take out one hydrogen, you replace it with chlorine. It can be any of these hydrogen, you take out one, you replace it with chlorine, okay? 12 times 4 plus 9 times 1 plus 35. Well, why do I use 35? Because chlorine exists as isotope 35 and 37. I'm sure you've done this term called isotopes. This is a exact number, okay? It's a result of isotope. The one given in your periodic table is mass number, which is atomic mass number, okay? It's an average mass, all right? So what actually happened is I can use 35 there, but they shouldn't differ that much. It should be able to tell you, is it going to be 127 or is it very far off, okay? 12 times 4 plus 9 plus 35 is 92. It's very far off. Even if you have 37, it's just going to give you 94, very far off. One chlorine is not going to be enough. I need more chlorine. Therefore, that is wrong. C4H8. Why do I go for 8? Well, because now I would have replaced another hydrogen with another chlorine. So altogether I have 2 chlorine. What is my MR then? 12 times 4 plus 8 plus 35 times 2. 126. I know what they have done now. They have used 35.5. That will give you exactly 127. Alright? But I hope you can see the idea. Even when I use the pure isotope, which is 35, I still get the value close to that, meaning to say there must be 2 chlorine. That means I replace 2 of the hydrogen with 2 chlorine. I can say it's C4H8Cl2. If you want, I should probably go back to 35.5 because that's what your periodic table will show you. But I know my chemistry, it will still be correct. You got to have 2 chlorine to be close enough to what you actually observe, yeah? Now they want you to suggest, because they want to suggest a structure, you want to show all of the bond and all the atoms. Out of all of this, where are you going to take the hydrogen out? Does it matter? Does not. Just take out any two hydrogen. Can be here and here, can be here and here, can be here and here. Does not matter. Do they give you any information? No, they just say suggest, right? So realistically speaking, I could just pick out any one of them. I am just going to do that, okay? But as long as you have 2 chlorine, you will be fine. Will it be 2 chlorine then? Don't know. Will it be 1 chlorine then, 1 chlorine then? Don't know. Suggest a structure. Does it have this formula? Of course it does. 4 carbon, 1, 2, 3, 4, 5, 6, 7, 8. Add hydrogen, 2 chlorine. Yeah, that's fine. Okay. It's just suggest, alright? These are the kind of question that will make you think a little bit more, yeah? So given the percentage mass, you should be able to work out the empirical formula. And then how do you work out molecular formula? Well, they give you the molecular mass, right? Molecular mass is 127 there. So start by working out the empirical formula, which is 29.7, 4.3, 65.9. You gotta label them, the mass per 100 gram. So mole is going to be mass over the MR. Well, the AR, I guess, relative atomic mass. Then you know the next thing is you need to divide by the simplest ratio. Simplest ratio means divide by the smallest number. In this case, that is the smallest number. That divided by itself is just 1. I don't need to do anything there. That divided by 1.856. That is 1.33. Oh, I can see a difficulty here already. Anyway, I'll talk you through it in a little bit. 2.3. Now, what is the first common mistake? The first common mistake people will make is, when I say people, I mean students mostly. This is 1.3. They will say it's just 1. Here is 2.3. They just say it's 2. There's something special you learn in primary school. 1.33 is equal to 4 over 3. Okay, what is 2.33 then? 2.33 is 2 plus 1 over 3. Because 1 over 3 is 0.33. What is 2 1 over 3? That is 7 over 3. Funny, right, how we are doing fractions now? Okay, primary school, yeah? So what you have is actually 4 over 3 is to 7 over 3 is to 1. Multiply by 3 all side. Well, throughout, I guess. 4 is to 7 is to 3. 4 over 3 times 3 give you 4. 7 over 3 times 3 give you 7. 1 times 3 give you 3. Right? Is that correct? Let me think. That doesn't work out. Because the molecular mass is only 127. I was wrong, I guess. I must be wrong. That means all of this is just wrong. All of this is just wrong because if I have that, then why did they tell me the molecular mass was 127? Oh, I was wrong. They say another compound. So the molecular mass is not 127 because the 127 was one of these compound. Actually, I read more carefully. It's another compound. So that is not 127, meaning I'm okay again. I'm okay again. It must be 473. Okay, so it must be C4H7Cl3. This is another compound. And I don't know. So they've replaced one more of the hydrogen with another chlorine. So instead of 8 hydrogen, 2 chlorine, you got 7 hydrogen, 3 chlorine. Why do I sound unsure? Because typically the simplest ratio of the atoms will just give you empirical formula. But they want to calculate molecular formula. But this is my only explanation really. I mean, they don't give me the molecular mass. So I can't get it without the molecular mass. And this is not the molecular mass. Trust me, it's not. Okay? You can work out the molecular mass from this, and it's not that because it's another compound. And you can tell it has substituted one more time. It has substituted another hydrogen for another chlorine. So it won't be 127, yeah? That's the best I can do, really. Okay, it must be that. All right, but I hope you can understand the fractions. So be careful when you see this 1.33 and 2.33. You got to think about your fractions. Yeah, your one third as a fraction.